find a fourth degree polynomial equation with integer coefficients for which negative square root of 3 and 2i are solutions. Now when a polynomial equation has integer coefficients, that's numbers like 1, 2, 3, or negative 1, negative 2, negative 3, if negative square root of 3 is a solution, then positive square root of 3 must also be a solution, or the coefficients wouldn't be integers. So we not only have negative square root of 3 as a solution, we also have positive square root of 3 as a solution. Similarly, not only does 2i have to be a solution, but negative 2i also has to be a solution. So we actually have to have 4 solutions, which will give us a fourth degree polynomial equation once we multiply it out. Each of these corresponds to a factor. Negative square root of 3 would correspond to x minus negative square root of 3. Square root of 3 would correspond to x minus the square root of 3. 2i would correspond to x minus 2i, and negative 2i would correspond to x minus negative 2i. And this would be equal to 0, which would give us a polynomial equation. Now let's multiply this out. First of all, let's write this as x plus the square root of 3, and then we have that x minus the square root of 3. Then we would have x minus 2i times x plus 2i, and that equals 0. Now looking at this carefully, when we multiply this, this would actually multiply to be x squared minus 3. And this multiplies as x squared plus 4. And then when we multiply these two binomials, we get the trinomial x to the 4th plus x squared minus 12 equals 0. And this is a fourth degree polynomial with integer coefficients for which negative square root of 3 and 2i are solutions.